Welcome to the deep dive. Today we're jumping into injection molding. It's everywhere, making all sorts of plastic parts.
Absolutely. Super important process. But, things can go wrong. Defects happen.
Right, and those defects can mess with quality, drive up costs. So that's our mission today. Yeah.
Exactly. We're going to unpack some common injection molding faults, drawing from a really detailed technical guide.
The goal being to help you quickly spot these problems and, crucially, know the fixes.
Spot on. Let's get into it.
Okay, first up, sink marks. Those shallow dips you sometimes see, often near ribs or bosses.
Yes, sink marks. They often mean the material shrank too much as it cooled. Or maybe not enough packing pressure or time holding that pressure.
Or the part's just too thick in places.
Right, especially near those features. The guide suggests keeping rib thickness, ideally between 40 and 60% of the main wall. Thinner ribs cool more evenly with the wall.
Ah, okay. So solutions are like increase packing pressure, redesign for more even thickness.
Precisely. Or maybe move the gate where the plastic enters. Oh, and there's a neat trick in the guide to tell sink marks from internal voids.
The heat test thing.
Yeah. Gently heat the area. A sink mark might collapse more. A void, being inside, won't react the same way. Both are shrinkage, just different types.
Interesting. Okay, moving on. Flow lines. Those kind of wavy, off-color lines, usually near the gate.
Flow lines, often caused by material that doesn't flow easily, or injecting too slow, maybe unevenly.
Low temperatures, too. Melt or mold temp.
Yes, those can definitely contribute. And again, variations in wall thickness don't help.
So fixes involve speeding up injection, raising temps, maybe making the gate bigger.
Right, and keeping wall thickness uniform. But there's that interesting speed paradox mentioned.
Oh, yeah, too slow gives you flow lines, but too fast
Can cause jetting, another defect we'll get to. It's a balance. Depends heavily on the mold design and the specific plastic you're using.
makes sense. Okay, next, warping. The part comes out twisted or bent.
Warping often happens with materials that shrink a lot or unevenly. Semi-crystalline plastics are more prone to this.
And uneven cooling is a big factor, right?
Yeah.
Or, again, non-uniform walls.
Exactly. So the solutions focus on getting really uniform cooling, designing uniform thickness from the start, and maybe choosing a different material if possible.
Seems like warping is tied into everything, material, design, process.
It really is. It underlines why design for manufacturability, DFM, is so critical. You got to think about how it'll actually be molded.
Good point. What about weld lines or knit lines? Those visible seams where plastic flows meet?
Right, weld lines. They happen when the melt front splits maybe around a hole or pin and then rejoins.
Yeah.
Or if you have multiple gates.
And the causes are things like low melt temp, injecting too slowly.
Yeah, or obstructions, like you said. Low temp means the flows might not fuse together properly when they meet.
So you'd increase temperatures, maybe inject faster or with more pressure, optimize where the gates are. Venting helps too, I imagine.
Absolutely. Good venting lets trapped air escape. And it's worth noting, these weld lines can actually be weak spots in the part because the polymer chains don't fully entangle across the line.
Okay, got it. How about flash? That extra thin plastic leaking out.
Flash, usually at the parting line or around ejector pins. It means plastic got where it shouldn't.
Too much injection pressure, maybe? Or not enough clamp force holding the mold shut.
Exactly those.
Yeah.
Or the mold surfaces aren't sealing perfectly, maybe worn or dirty.
So solutions are increase clamp force, dial back the injection pressure or speed, and keep that mold clean and well-maintained. It's a balancing act.
It is. Balancing injection versus clamping. And runnier, low-viscosity materials are more likely to sneak into tiny gaps and cause flash.
Right. What if the opposite happens? The part doesn't fill completely. Short shots.
Short shots, incomplete parts. Often means the plastic is too thick, too viscous to flow everywhere. Or not enough pressure, speed, or just not enough plastic injected shot size, too small.
Small gates or runners could block the flow too. Or bad venting trapping air.
All potential causes. So the fixes are pretty straightforward. Increase pressure, temp, shot size.
Yeah.
Make gates and runners bigger if needed. Improve venting so air can get out.
Basically, the plastic solidifies before it reaches the end of the line.
That's the essence of it, yeah.
Okay, what about burn marks? Those ugly black or brown spots?
Burn marks, often found at the very end of the flow path, usually caused by trapped air getting compressed so fast that heats up and scorches the plastic.
Like a diesel engine igniting fuel, the dieseling effect.
Exactly, that's the term. Or just excessive melt temperature, or injecting way too fast. But poor venting is a very common culprit.
So improve the vents, maybe slow down, reduce temps.
That's the approach. Let the air escape.
Gotcha. Now voids. Bubbles or cavities inside the part.
Voids, yes. They can be different things. If it's due to shrinkage after the outside skin has solidified, that's often a vacuum void, not enough packing pressure to compensate.
And other bubbles could be moisture.
Could be moisture turning to steam, especially if the plastic wasn't dried properly, or trapped air due to poor venting, or even volatiles released from the plastic itself if it overheats.
So for vacuum voids, increase packing. For the others, dry the material, improve venting, maybe optimize cooling.
Right. And the guide mentioned that heat test, again, can sometimes help distinguish between a shrinkage void and a gas bubble.
Okay. Jetting, you mentioned that earlier, snake-like lines near the gate.
Jetting. That happens when the molten plastic squirts through the gate too fast, like a jet, into the open cavity instead of flowing smoothly along the mold wall.
So it doesn't create that nice progressive fountain flow?
Exactly. It creates defects as it folds over itself. The fix is usually to slow down the initial injection speed, maybe increase the gate size, or aim the gate so the plastic hits a wall immediately.
Control the flow right from the start.
Precisely.
And delamination, where the surface layers peel off?
Delamination. Looks like flakes or layers separating. Often points to contamination, maybe bits of a different plastic type mixed in, or too much mold release agent interfering.
High shear stress during injection can cause it, too.
Yes, excessive shear can sometimes prevent layers from bonding well. So solutions are keeping materials pure, using release agents sparingly, and optimizing the process to reduce shear.
Cleanliness and compatibility are key.
Yeah.
What about just the wrong color? Discoloration or streaks?
Discoloration. Could be contamination from a previous run with a different color, or the colorant itself isn't stable at processing temps. Poor mixing is another one.
Or the material degrading from too much heat?
Yeah, overheating can definitely cause color shifts or streaks. So thorough cleaning between runs, using stable colorants, ensuring good mixing, and keeping temperatures and residence time in the barrel under control.
Got to rule out contamination versus degradation. Right. Splay marks, silvery streaks, also often near the gate.
Splay marks, or sometimes called silver streaks, very often caused by moisture in the plastic, especially hygroscopic types like nylon or ABS.
The moisture turns to steam and messes up the surface.
Exactly. That rapid expansion disrupts the melt front. Can also be caused by material degradation releasing volatiles or just trapped air.
So the number one fix is thorough drying of the material.
Absolutely crucial for materials that absorb moisture. Then, controlling injection speed, temps, and ensuring good venting helps too.
Okay, one last one. Ejector pin marks. Little dents or raised spots where the pins push the part out?
Yeah, those marks usually mean the part was still a bit too soft or hot when ejected, or the ejection force was too high.
Or the pins themselves are too small, or in the wrong place, not enough draft angle on the part.
All possibilities. So solutions involve increasing cooling time, adding draft angle to make ejection easier, reducing the ejection force or speed, and maybe using more pins, larger pins, or relocating them to stronger areas.
It's about the force needed versus how strong the part is at that exact moment. Wow, okay. That's quite a list of potential pitfalls.
It is, but many are interconnected.
So what's the big takeaway for someone troubleshooting these?
I think the guide points towards a systematic approach. Look at your process parameters. First, temps, pressures, speeds. Then consider the material itself. Is it right for the job? Is it dry? Then look at the mold design and the machine's condition. Process, material, mold machine.
And remember that changing one thing can affect others, right? Like fixing flow lines might risk jetting.
Exactly. It's often about finding the best compromise or trade-off for that specific part and material.
So thinking ahead, what's something you, the listener, should maybe mull over after this?
Well, we've touched on how material properties influence these defects: shrinkage, viscosity, moisture absorption. So a final thought might be, based on these common problems, what specific material properties would you want to understand more deeply to really get ahead of potential molding issues? Something to explore further.